Welcome students of class 9. Today I will solve question number 4 of exercise 8.2 of the chapter quadrilateral. Previous day we have solved question number 3. Okay students, so statement of the question number 4 that ABCD is a trapezium. First of all, what is trapezium? Trapezium is one type of quadrilateral whose only one pair of sides is parallel. Only one, not both. Only one pair of sides are parallel. This is parallel to this. This type of quadrilaterals are called trapezium. Okay. So one trapezium is given here. One trapezium is given here. That is ABCD. Okay, where AB parallel to CD. This is also given. AB parallel to that parallel sides are also mentioned. AB and CD are parallel. BD is the diagonal. So draw the diagonal BD, and E is the midpoint of AD. AD is the midpoint. Okay, is the midpoint of AD, and a line drawn through E. A line drawn through E parallel to AB. Parallel to be intersect BC at F. So that line through point E, one line is drawn parallel to AB. Parallel to AB, this is parallel. Intersect at BC at point F. Okay, and that line EF also intersect the diagonal. I am giving that name G. Okay, so that line segment E drawing through E intersect the diagonal BD at G and BC at F. We have to prove that F is the midpoint of BC. So F is the midpoint of BC. This is our required proof. Okay. So students, what is given? That is ABCD is a quadrilateral where AB parallel to CD and E is the midpoint and BD is the diagonal. E is the midpoint of AD. A line drawn through point E is parallel to AB, which intersect the diagonal BD at G and F BC at F. We have to prove that F is the midpoint. So F is the midpoint means CF equal to BF. Okay, that is our required proof. So first of all, students, consider the triangle. In triangle ADB, just think about the triangle ADB. Okay, and forward that about that portion G to F and other portion. So one thing it is clear, EG parallel to AB, that is given. EG parallel to AB, that is given, and E is the midpoint. E is the midpoint of AD. E is the midpoint of AD. So what can you say by converse midpoint theorem? That a triangle ABC, a line through the midpoint of one side is parallel to the third side. Then that line intersect BD at G by midpoint, converse midpoint theorem, by converse midpoint theorem. By converse midpoint theorem, you can say that G is the midpoint of BD. Okay, so G is the midpoint of BD. Just so E is the midpoint of AB and G is the midpoint of AD. This is I proved from by using converse of midpoint theorem. Okay. Now another thing. Now take the triangle in triangle BDC. In triangle BDC, first of all, students, that EA parallel to AB, it means, and AB is parallel to CD, it means EA parallel to DC also. EF in just cut this portion, that is GF parallel to CD, that is given. Okay, and G is the midpoint of BD. Triangle BDC, GA parallel to DC and G is the midpoint. Then by converse midpoint theorem, by converse midpoint theorem, what can you say? That F is the midpoint of BC. F is the midpoint of BC. So this is our required proof. We prove this by using converse midpoint theorem of triangle. Okay, so again I am explaining that from the triangle ABD is the midpoint and EG parallel to BC, it means G is the midpoint of BD. Next, GF parallel to BCD, and consider the triangle BDC as G is the midpoint, GA parallel to CD, so F is the midpoint of BC. F is the midpoint of BC. This is our required proof. Okay, so we have solved question number 4. In this question, student, if you have any problem regarding this video and any other video, you can ask me in e-portal. Next day I will try to solve question number 5 of the chapter quadrilateral, and I hope the concept or the subject matter of the question number 4 is clear to you. Thank you, students.